Welcome, Mr. Rasmus Lerdorf.
Thank you, and good morning. My slides are online at that URL if you want to follow along or check them later. My Twitter, at Rasmus. So, I started this thing some 20 years ago now. I released the first version of PHP. And it's making me feel quite old these days. There are some contributors now to PHP, some core contributors, who were not alive when I released the first version of PHP. And that's very crazy to me. So this announcement on June 8, 1995 looked like this. There was a lot of stuff in there. And if you get a chance, it's kind of fun to read through it because it's kind of a snapshot of what the web was like in 1995. The way I do things is I always start with a problem, and I only build things to solve problems. So this was a list of all these problems that people had. And the way I presented PHP was, have all these problems. These are the kinds of problems that you can solve with this tool. And it doesn't really talk about PHP as a language. There's only a little bit here that gives you some hint as to what PHP actually was. And my idea of PHP is very, very different from what or how people use PHP today. I released PHP as a set of tools, and my grand scheme was to build a C API for the web. That's what I thought PHP actually was. So I hooked people a little bit with a list of problems that they could solve with PHP. But what I really wanted to do was release this API and show people, hey, here's a tool set, here's an API that you can use to solve any problem that comes up. I've solved some problems for you already as an example, but in behind the scenes, this is what PHP was. And this is what I thought the world might be interested in. Turns out I was completely wrong. Nobody cared about my C API. They just wanted to solve problems. And they would come back to me and say, well, I now need to solve this problem. How do I do this? And it's like, well, it's easy. Here's how you do it in the C API. And I would solve it for them to show them. And they would say, thank you. Now I have this problem. Could you solve this problem for me as well? And I got more and more frustrated because I kept showing people how easy it was to solve problems using the C API, and they just kept bringing me more and more problems. Nobody wanted to write C code, which to me was very frustrating because as a C developer, I'm not a PHP developer, right? PHP is not written in PHP. PHP is written in C. So I am much more a C developer. And I thought, and I still kind of think, that you need a strongly typed, compiled language to build complicated software. And this is why I thought the C API would be a good idea for how to solve the web problem. And it's quite simple. So what I actually did was I built a little parser that would pick out tags in HTML, and I made it really easy to link up a piece of C code to that tag. So if you wanted to have a cosine tag to calculate the cosine of a number, you could build it like this. You just write a C function that pulls the number off the stack. So everything was stack-based. So arguments going into my C API got put onto the stack. You would manipulate that number, and then you would push the result back onto the stack. And that latest version or that latest value on the stack would then get output into the HTML page, right? So pop it off the stack, do something to it, in this case call cosine on it, and then push that number back onto the stack. So you didn't have to understand anything about your web server, Apache, anything like that. You didn't have to understand HTTP. All you had to do was pop and push on the stack and then implement your actual business logic in this section here. And then you could then spit out COS, right? You can do echo COS and it would do its thing. I thought this was a very powerful way of solving the web problem. The only part that people liked was the fact that they could put stuff into the HTML. Nobody wanted to write anything in C. I think part of the reason was that in 1995, the web was exploding. There were so many new websites and so many companies and so many people needed to build the web, and there just weren't enough C developers. C programmers are kind of a rare breed, and there are many more people that know how to do a bit of HTML, and the same was true in 1995. People could just barely handle HTML. Ask them to build something in C and compile it, whoa, way over their heads. And that's really the reasoning for PHP as we have it today, is that the explosion of the web forced a whole bunch of people who didn't have a lot of experience programming to scramble and look for a tool that fit their experience level. And PHP fit that, at least this part of PHP. The fact that you could take an existing HTML page and just add a couple of little things to make it dynamic was very, very easy for people to get started with. Now, 20 years later, PHP has come a long way. We're going to be releasing PHP 7, probably the final version maybe by October or so this year, depending on how testing goes. We should have an initial release candidate sometime in the next 6 to 8 weeks from now. The biggest thing that I think people will notice is that it's fast. It's really, really fast. Over 100% performance improvement on most real-world applications. So if you have a WordPress or a Drupal or even your own custom-built stuff, chances are pretty good that your website will be twice as fast after you upgrade to PHP 7. And it shouldn't break anything. There are a few minor changes here and there that you need to go through the release notes, but for the most part, pretty much every piece of code that runs well in PHP 5 will run unchanged in PHP 7. It'll also use less memory, and native thread local storage for threaded environments, specifically Windows. There are some Unix-based threaded ones as well, but specifically Windows, the code is cleaner and faster if you happen to be using PHP on Windows. We also have some interesting new features. One of them is a file-based cache for the opcode cache. So the way PHP works is you have a PHP script on disk that gets compiled down to a set of opcodes, and those opcodes can be cached in shared memory, and then we execute those opcodes. So the second time you hit a new script, it won't have to go to disk. It can execute out of shared memory, which is much, much faster. It tends to be about 10 times faster than just reading the script from disk on every request. However, if you restart your web server for log rotation or something like that, you lose this memory cache, and you have to recompile everything. So one feature we've added is the ability to cache on disk as well, the compiled opcodes, so that on a restart, if you lose your cache, your memory cache, you can grab that cache from disk. It's not as fast, obviously, but it means that on a restart, the performance impact won't be as big. It's also AST-based. AST is an abstract syntax tree. So when we parse a PHP script, we turn it into an AST. And we have tools that let you grab that AST. So you can take this abstract syntax tree export it and run tools on it. Things like static analysis and optimization can be run on the AST. So I'm hoping this will encourage tool developers to build interesting tools around this. IDEs specifically will be able to do better context analysis and static analysis on the code as you're typing along in your editor. We've also added more typing. One of the type features is return types. So you can specify that a function has to return a specific type. And if you get it wrong, it'll throw a catchable fatal error. So in this case, we have a getConfig function. And here we specify with colon array saying that getConfig should return an array. If we do not return an array, in this case I return an integer, then when we run this code, it's going to tell you return value of getConfig must be of the type array, integer returned. And it'll tell you the line number and file, of course. For passing parameters into functions and methods, we have added scalar type hinting, or coercive scalar typing and strict scalar typing. By default, it'll be coercive. So if you say, I want a string, an integer, and a float, these arguments, if they can be converted, will be converted to string, integer, and float. So in this case, I'm obviously not passing in a string, an integer, and a float. But we can coerce them. We can change the type and make the code work. You can also turn on strict typing, and you can say, I don't want that code to work. I don't want it to try to make it work. I want to know if I pass in the wrong types. So in this case here, it's going to give you a fatal error and say, the first argument must be of type string, but I passed in an integer, right? For testing and debugging, this is quite useful. For production code, perhaps less so. We've added anonymous classes. So instead of having to define a class and instantiate it, just like closures, anonymous functions, you can have an anonymous class that you basically define on the go and use it right away. We've added this thing called a null coalesce operator. It comes from SQL. Basically, it's going to, something like this will return the first true in the PHP truish sense, the first true value. So in this case, A is null, B is 1. So null is not true, B is true. So it's going to return B in this case. Between C and B, C is 2, B is 1. In this case, C is the first true value, so it's going to return 2. Between A, B, and C, A is null, right? B is 1, so in this case you get B. And between A, X, and C, X isn't even defined. So in this case, C is the first true value. And this does it without any sort of warnings. Other operators, if you try to do A plus X, for example, or just echo $X, you're going to get an undefined variable warning. The coalesce operator doesn't give you any warnings. It skips past any undefined variables. This is to avoid having a bunch of isset calls. If you've been doing any type of PHP development, you know you'll do isset $X and then do things on it to avoid warnings in case it's not defined. We've also added the spaceship operator. For Star Wars geeks, it should be obvious why it's called the spaceship operator. And it's basically a way to simplify code like this. So if you have a comparison function where you want, if A is less than B, return -1. If A is equivalent to B, return 0. If A is larger than B, return 1, right? So you have a lot of boilerplate code that looks like this. This does the same thing all in one operator. And we mostly added it because people tended to get this wrong. And they ended up writing comparison functions that didn't do this correctly. and that weren't stable in the sense that if you switch the order of A and B, the result didn't always change. And it made for a lot of bugs. This is a way of making sure that this comparison works correctly. We've also added a way to catch fatal errors if possible. So we've turned a number of fatal errors into exceptions, which means that if you wanted to, you could catch them and try to do something more intelligent with them. If you don't catch them, an uncaught exception is still a fatal, so your existing code won't behave any differently, but you have the ability now to go in and catch a fatal. For example, if you're trying to call a method on a null object, previously you just get a fatal error. This is call to member function method on a non-object, right? Now you get an exception, and you could catch it in case you think this object may not exist. Of course, it's a really bad idea to write code like this that calls methods on objects that don't exist, but there are times when it can't really be avoided. We've also added closure call, which lets you basically call directly a closure as you defined it. And we've removed a whole bunch of really, really old PHP 4 era things that have been marked as deprecated for a long, long time. Things that would display warnings if you tried to use them in the past 10 years or so. Now a lot of these have gone away. For most of these, it shouldn't affect you. This one might, the old MySQL extension. We and the MySQL folks have been trying to migrate people to use MySQL I, or at least PDO MySQL, instead of this really old and somewhat insecure MySQL extension. It's still available in Pecco, and distributions are still going to ship this MySQL extension. So it's not like your code can't work if it's using the old MySQL extension. It's still out there. It's working with PHP 7. So, but this is more us hinting and trying to push people a little bit to get onto a modern MySQL API. And you can go through this list and see some of the things that have changed. We have a number of new reserved words. So if you have classes named any one of these, you're going to have to make some changes. So this is probably the biggest source of breaking legacy code. Drupal 8 had a string class, for example. They fixed that. But Drupal 8 didn't work with PHP 7 for a while because of this string class that they had. And because we're doing scalar typing now, we needed that keyword to specify that this is a scalar type of string as opposed to being an object named string. A few other new things. A lot of cleaning up around 64-bit and also underflows and overflows of integers. You can now have strings that are longer than 32 bits in length. That's a really, really long string. But sometimes people will put an entire movie into a string variable, for example. It sounds a little crazy, but they do that. There's also now a parse error. If you're writing an octal number, that's illegal. So 0855 is not a valid octal number. You're going to get a compile error. A few other changes. All these types of things that you really should never do will now work as you expect. I'm not so sure how I feel about fixing some of these cases, but we often get bug reports from people trying to do really crazy things, like having a closure, calling a dynamic closure which has an element which basically returns an array, and that array is an array of closures, and basically stringing together all these operations all in one go that you might expect should work, but doesn't necessarily work in PHP 5. Everything is now left to right evaluated. And this is another thing that might break your code. In this case, if you had a property that's, if you're trying to get to a property that is stored in an array, so belongs to column is an array that's in a property basically, then PHP 5 would dereference this part first, and then that string would become the name of the property. In PHP 7, it does completely left to right. So it's going to dereference this first, and then it's going to apply the array index to it. And that can be a slight problem. All you have to do, though, to get back to the PHP 5 approach is if you want it to work that way, you just put in curly braces. And I had to do that in 2 large applications that I tested. But it's not that hard to find because you get a very nice error on it. All right. We have a new Unicode code point escape syntax, so you can do /u. And then put the code point that you're trying to do. In this case, I put 2022E, which is the right to left Unicode code point, and then smiley face, right? So it ends up writing things right to left here. And as I said, hopefully a first release candidate in June 2015. Now, that's a lot of changes, and it's been a lot of effort to get to the point where we are more than twice as fast on many things. We had mostly 3 people working on it. Dimitri, Shenshen, and Nikita. These 3 guys have been working for the past 1.5 years on this. And it's kind of interesting how they approached it. So they started with WordPress. They said, we're going to take WordPress 3.6 and we're going to see what we can do to make WordPress go faster. So in January 2014, looking at 100 requests for the front page of WordPress, those 100 requests on a pretty slow box took 26 seconds, and it took 9.4 billion machine instructions to deliver the page. Then they looked at those numbers and say, okay, what do we need to do to make that go faster? How can we eliminate some instructions, and which instructions are taking the most time? And they systematically went through. So by March, they had it down to 23 seconds and 7.4 billion instructions. And as you can see, by November, December, they had cut the time in half. So by December, that 26 seconds was down to 12 seconds, and the 9 billion instructions were down to 2.9 billion instructions. So the number of instructions was cut by a factor of 3, basically. And it's kind of magic, because you have a very complex application that you're trying to remove 2/3 of all the instructions that make up that application without breaking it, without changing anything in WordPress itself. And it's worked extremely well. So I have a couple of benchmarks to show 2 main things. First, that PHP 7 runs all the typical popular PHP applications out there. And second, just how fast it runs it. But like any benchmark, don't trust my benchmarks. There are all kinds of things that may not apply to your environment. You should test your code yourself. You should do your own benchmarks on the code that matters to you. But if you want to recreate my benchmarks, if you think I'm lying to you, I have provided all the specs for everything. You can build a machine, you can get the right motherboard, you can get the right CPU, you can get the same memory, install all the same versions. If you go through and do all the same configuration, build with the same version of GCC, you should be able to recreate exactly my environment. Or if you think that I missed something, you can go through my configuration and find the little thing that you might be able to tweak to speed something up or slow things down. So this slide has all those things. Now, the first one is Drupal 8. So Drupal 8 isn't released yet, but it's going to change the world of Drupal, I think. So here, all these numbers are with an opcode cache installed. So PHP 4 on my test box returned about 1,350 requests per second. Could handle 1,350 requests per second, right? PHP 5.5 was a little faster, 1,384. PHP 5.6, 1,428. With every version, we try to make things faster. But it's been pretty slow increases until PHP 7. Suddenly, we jump now to 2555 requests per second. HHVM 3.7 is pretty fast as well, but it's at about 1900 in this case. And if we look at latency, so obviously for requests per second, higher is better. For latency, and this is at 20 concurrent clients, for latency, lower is better, right? This is the amount of time it takes for the page to return. With PHP 5.4, it was 15 milliseconds. With PHP 7, we're down to 8 milliseconds. So basically, we're returning the HTML in half the time, which means that the applications are going to feel faster, they're going to feel snappier. When you upgrade your web server to PHP 7, things will just feel a little bit nicer. It'll feel more responsive. I also did numbers for, so these are for 10 requests or 10 concurrent clients. So 10 parallel browsers hitting your site. This one's for 20, this one's for 40. And the numbers don't change that much for the different versions. They all scale pretty much the same. For latency, if you really care about having a super fast website, you want to make sure you don't overload your servers. You can see at 10 concurrent clients, 20, 40, the latency really suffers. Less so for PHP 7 and HHVM, but still, if you want the fastest experience, you want to have enough servers so that you don't put 100 concurrent clients on a machine that only has 4 CPUs, for example, or 4 cores. All right, WordPress. This is one of the cases where HHVM is actually slightly faster than PHP 7. It's getting pretty close. When I did these benchmarks 2 months ago, HHVM was further ahead. We've been catching up in the PHP world pretty quickly to WordPress. By release, maybe we'll be tied. We'll see. It's been pretty fun with the Facebook folks, actually, because there's a bit of competition between the two projects now to see who can go faster. And both projects have been using WordPress as our code base, as sort of our benchmark code base. So a lot of optimizations we've done have been targeted specifically for WordPress, which is one of the reasons that it isn't just 100% faster, as you can see. If you're running WordPress on PHP 5.3, you're getting about 200 requests per second, right? And upgrading to PHP 7, you get to 600 requests per second. So you're basically getting 3 times the speed out of it. And you see that on the latency side as well, right? At 20 requests per second, latency on 5.3 was 95 milliseconds. That's dropped down to 33 milliseconds for PHP 7 and 32 for HHVM. So if you have a large WordPress installation that might take 10 cloud instances somewhere, if you upgrade to HHVM or PHP 7, you now only need 3 cloud servers to handle the exact same amount of load, which can be a big deal. At those numbers, it's not a big deal, but imagine a Yahoo or Wikipedia that have way more than 10. They have hundreds of servers. The fact that they could eliminate 2/3 of their servers is a huge, huge thing. So some other large popular applications, PHP BB, it's a bulletin board system, web form type system. Again, PHP 7 is more than twice as fast as PHP 5.3 and not quite twice as fast as PHP 5.6, but faster than HHVM. And again, latency much lower. Latency drops from 65 milliseconds down to 28 milliseconds. MediaWiki, here HHVM has worked quite closely with Wikipedia to make MediaWiki run really fast on HHVM. We haven't really tuned anything for MediaWiki in PHP 7, so we're not quite up to speed with HHVM here. So if you're using MediaWiki, chances are HHVM is probably a better choice for you, because we are a bit slower. Although, I mean, it's still much, much faster than running MediaWiki on PHP 5. OpenCart, this is a point of sale type thing, or a shopping website with your shopping cart, all the typical things. You can see there's no 100% increase here. In fact, there's barely any change at all. If you upgrade from PHP 5.6 to HHVM, you're not going to see much difference. PHP 7 squeezes a little bit of performance out of it. And the reason for this is that when I profiled this application, I looked at what it was doing. It was spending 96% of its time in MySQL. Right? So if you have an application that's just grinding away with SQL queries, there's nothing we can do in PHP or HHVM that's going to make your SQL queries return faster, right? You need to not do full table scan queries. You need to optimize your SQL or get a faster database if you want your site to go faster. There's simply, when we're only 4% of the problem, even though we make our 4% twice as fast, it's only going to be a 2% increase on your overall performance of your site. So if your code looks like this, yeah, sorry, you're out of luck. We're not the problem. You need to look at your code, because this is very database heavy code. CMS system, Wardrobe CMS. This is a Laravel application. So if you're using a the Laravel framework, this is a good indicator of the speed increase that you might see on your application. And you can see it's basically 2x going to PHP 7. HHVM doesn't run this one very fast, actually. Geeklog, another random application I downloaded just to see if it would work perfectly, much faster. Magento. Magento is a beast of a application. It's another shopping cart application. This one we could speed up a little bit though. Not quite 100% speed up, but close, at least to these ones. But HHVM does run this one slightly faster as well. Latency-wise, it's pretty similar. And this is a very complicated application. I haven't quite figured out why HHVM is faster on this one. The thing to keep in mind between PHP 7 and HHVM is that HHVM is a JIT, and a JIT is really good at running repetitive code that takes the same branches all the time. It's really good at speeding up that type of code. Whereas PHP 7 is not a JIT yet. So we don't have this ability to speed up these hotspots. So if your code has a lot of hotspots, it keeps making the same decisions over and over again, it might run better under HHVM. Of course, if your code looks like that, maybe you shouldn't have all these branches. Maybe you should just hard code it. If every single time you execute it, it does the same thing, why do you have all the conditions in your code? Just hard code it. But we will add a JIT at some point to PHP 7. So from a performance perspective, the really exciting part is that PHP 7 has gotten to this amount of performance without a JIT. We still have our JIT card that we can play, to attack hotspots. And when we do that, we get the performance increase of a JIT on top of the base performance that PHP 7 has, which should be very, very cool. A few more applications. Track is a bug tracking system. Runs quite well in PHP 7. Cache is a status page. So as a company, if your site goes down, you can't really have a status page on your own site because your site's down. So typically you will host a status page somewhere else. You might get an Amazon server or DigitalOcean server somewhere, and you can install this cache on it. And it's a very nice little application to host status pages. Runs really, really fast in PHP 7. Moodle is an educational, I don't know, my son's school use it. They keep track of their class schedules and homework and all this stuff. My son logs into Moodle twice a day probably. Runs really well under PHP 7. I couldn't actually get this one to work under HHVM. There's some incompatibility there. Another shopping cart application that's heavy on databases. But you get the idea. PHP 7 is super, super fast. If you're interested, if you're using PHP, you should be interested in PHP 7. And if there's one thing I can ask you today is please, please help us test your code before we release the final version so that we don't get hundreds of bug reports the day after we release. It'd be really nice to hear about it early so that we can fix the problems that stop your code from working for you before our release. And it's really easy. I provided a Vagrant box, which runs on top of VirtualBox, that you can get up and running in, I don't know, like 4 commands, and it takes a little bit of time to download the image because it's 1.6 gigs or something. But you guys have super fast internet here, so it shouldn't be a problem for you, right? And once it's up and running, you'll have a Rasmus approved development box with PHP 7. It actually has every version of PHP pre-compiled for you. So if you want to test your application on different versions of PHP, or if you're writing any sort of extensions in C, it's really easy to build it for multiple versions with this image. And you can switch back and forth between PHP versions just by doing new PHP and the version that you want, and then it'll make that active. So really fast way of doing it. You can also grab the latest version of PHP 7, so you just type make PHP 7, it'll fetch the latest code, it'll build it, it'll install it, and start it running. You can do it manually. So, if you find a problem, please, please report a bug to us so we can fix it for you. It's not that hard to do, especially if you use the image. Then it's a known environment. Then I can reproduce the bug in my image and I can get it fixed. 90% of the problems with bug reports is the reproduction part. As soon as we can reproduce it on something we know on the developer side, we can fix it. The bug is essentially fixed as soon as we can reproduce it. And the easier you make it for us to reproduce a bug, the higher your chances of a bug or the bug being fixed for you. Okay. I will be around a little bit today, so you can try to corner me and ask in person if that makes you less shy. But thank you very much.
Thank you. Thank you, Mr. Rasmus Lerdorf.